Before moving on to the principles of this design pattern, let's have a look at the scenario that we'll be um, solving using facade design pattern. So we have to design a paper printing application which end user application or client application will use to send the printing command. Now the thing is that um, all these subtasks or complexities involved in printing should be hidden from the end user application or client application. So when we send a printing command, a lot of subtasks have to be performed, such as switching on the printer, checking the uh, availability of the papers, and various more subtasks, and then at the last the printing will be done. So all these complexities and subtasks should be hidden from the client application. The client application should only know about, okay, I have to print I have to send the print command, or I have to send the stop print command. And the third point is that the API of the application should be simple and easy to use for the end user application or client application, which is nothing but that which I just told, that the client application, when it is using my application, then it should uh, be having a very simple API which should have uh, bare minimum methods to be called, and which should be very simple. In this case, it's just like start printing or stop printing. So now let's look at the principles of facade design pattern and try to link it with the scenario. So it works on the principle of least knowledge. So now if I link it with my scenario, the client application which will be using my printing application should be only knowing about that I have to send a command to start the printing, or I have to set the command to stop printing. Nothing else. It should not know about what all goes behind the scenes, what all subtasks are performed when a start print command is sent or when a stop print command is sent. Uh, the second point hides the complexity of the system from the end user clients, which I just mentioned. The my client application should not be aware about the complexity of my um, application or my printing product application, and it provides a simple unified interface to a set of interfaces in the system. So in order to do the real printing, I have to do a lot of subtasks which I just mentioned. So a lot of classes and interfaces will be involved in that, but all this should not be exposed to the client. The client should see a very simple and unified interface, which whose method it has to call, and those methods in turn should call the underlying interfaces methods. So let's see this via some code. So I talked about a printing application and a facade um, interface. So let's see first that facade interface. So it is my printer facade interface, and it has two methods: start printing and stop printing. My client applications will have the knowledge about this interface, and these two methods only, nothing else. And I talked about a lot of subsystems which are going to perform a series of subtasks to complete the printing job. So let's see those also. So first of all, I'm going to have a printer starter, which is going to have methods to switch on the printer or switch off the printer. To make it simple, here I'm just making this thread sleep for 2 seconds, and then I'm saying printer switched on, and I'm going to return true. If any exception occurs, then it's going to return false. So in a way, it's either going to return true when the printer is switched on uh, successfully, or it's going to return false if it's not switched on successfully. Similarly for switching off the printer also, if it is switched off successfully, it's going to return true or else false. Then there is a paper availability checker, which has a method check paper availability. Similarly, it's going to return either true or false. If papers are available, it's going to return true or false. And then I have the printer job, which is going to do the real printing. Here also, in the same way, it's either going to return true and printing turn, or it's going to return false. Similarly for stop printing method also, if printing is stopped successfully, it's going to return true or false. So these are my subsystems. But as per the principles of Facade, these subsystems, its methods, its interfaces should not be exposed to the client application because they are a bit complex in nature. A lot of things have to be done to do the printing. So all this my client application should not know. Now this principal facade, I'm going to create a printer facade implementation. I'm going to implement this printer facade, and I'm going to create instances of my subsystems like printer starter, paper availability checker, and printer job. If you are using Spring, obviously we are going to auto wire these things. Then from this printer facade interfaces, there are two methods, start printing and stop printing. So I'm going to override these methods, start printing and stop printing. And in this method, I'm going to call my subsystems. So if you see here, I have made these three boolean variables as false, is switched on, is paper available, is printing done. Then I'm going to call printer starter dot switch on. It's gonna go here and it's either going to return true or false, right? So if it returns true, I'm going to call paper availability checker, and it's going to check whether papers are available or not. It's gonna return either true or false, and if it returns true, I'm going to call printer job dot start printing, and again it's going to return either true or false. And then based on the outcome of this printer job dot start printing method, I'm going to return the same, whether printing is done successfully or not, right? Similarly for stop printing, first I will switch off the printer. Maybe I should make it like this. I should first stop printing and then switch off. Just give me a second. Let's make it like this. This printing is stopped. Then I'm going to return back this, right? So here also, first I'm going to call this stop printing method on one of my subsystem printer job. It's going to stop the printing, and then I'm going to switch off the printer, and I'm going to return whether this stop printing task has been done successfully or not, right? So let's have some client application also to test this out. So here I have my client application. So my client application has the knowledge only about my facade implementation and its interface. So it's going to create an instance of that, and as per the principle of least knowledge, it has the knowledge of only start printing or stop printing, nothing else, right? So it's going to call this, and it's going to print the results. So let me quickly run this. So here you see printer switched on, papers available, printing done, and it finally prints successfully and command status was true, right? So now similarly, if I have to stop printing, I'll just show that also. I have to just ask it to stop printing, and I'm going to run this again, and it's going to print. Printing is stopped, printer switched off, and the command status is true, right? So now let's correlate the principles of facade design pattern with this code. The first principle, as I said, principle of least knowledge. So my client application is having the least knowledge about my printing product application. It just knows I have to call start printing or stop printing. That's all. Second, it hides the complexity of the subsystem. So my client application is not able to see any complexity which is involved in start printing or stop the printing. All the complexity is hidden here in my facade implementation methods. So in this method only I am making use of my subsystems. They are not exposed to the client application. And and the third principle, it defines a simple unified interface. So if you see, I'm just my facade API is just having a very simple methods which I'll be giving it to the client application: start printing and stop printing. So these are the features of facade design pattern, and uh, there are few other advantages I would like to talk about. Apart from providing the simple API which you can see, uh, it also helps in in future if I want to update my subsystems, then I won't have to update my client API. So suppose in this facade implementation I'm making use of various subsystems and I want to update them or replace them, and suppose printer starter I'm using this, and maybe I'm in future I'm changing its methods name or return type or the way I implement it, then all these things won't impact my API which I am exposing to the client application. That will remain same. So whenever I make any update or change my application subsystem, there is no need for me to inform the client application saying that I have changed my subsystem, I'm also changing my client API, so please change your code also. So I don't have to do all those things. And secondly, I can have multiple sub facades also. So here you see a printer facade, and I am exposing it to the client application. Suppose in this uh, implementation you see say printer starter subsystem, and it is too complex. Like right now, if you see, I am just having a simple method switch on, but it might happen that in order to start the printer, a lot of other things have to be done. Then I'm going to create a facade at this level, and I'm going to um, give its API methods to my main facade implementation. So at the end, it's going to call only switch on method, and rest of the complexities will remain hidden here. So it's a kind of sub facade. So that was all about implementing the facade design pattern. Hope you got the basic theme of this design pattern and when to use it and what all advantages it brings to you. At the end, I just want to end by saying that whenever you design any product, then apart from what all which features it brings to you, um, there is a factor which should always be considered, which is how simple it is to use. Because when your product will be evaluated by the client applications or the vendors, apart from the features that your product provides, when they are going to evaluate your product and choose between your product and the other products of the same type, the ease of use is also a very important factor. So that's why we should always keep the things simple, keep the API simple for the end client applications. Thanks a lot, friends.